So, we are live. Hello, everyone. Welcome to our webinar for test automation engineers and everyone who is interested in this area. My name is Yuri Likhva. I work at EPAM Ukraine and actually as test automation engineer, and I will be your moderator for today's session. As I can see, our connection is good. Before we begin, let me remind you that this session is being recorded and will be available with all the materials later via the link. Also, please feel comfortable to ask any question you want. You can put them into our chat. We will answer them at the end of each presentation. Okay, let me introduce the agenda of today's meeting. We have today two topics and three great speakers from different countries. The first topic is flow models versus page object pattern, and the speaker is Peter Foldhazi. The second one would be how to protect against DDoS attacks, proactive and reactive modes, and speakers are Kakha, Chkhartishvili, and Pavel, Kuwchinow. Okay, let me introduce you to our first presenter, Peter Foldhazi, who is famous and active speaker on the multiple meetups and software engineering conferences in the Europe and in the USA. Test automation consultant, lead and quality architect at the EPAM Systems USA. As you may know, page object pattern is widely known and used amongst test automation engineers. It allows to model the application for tests, reusing certain elements, making the test solution more structured, and hence decreasing maintenance cost and learning curve. However, from many testers' point of view, it could be improved. For example, it breaks the single responsibility principle, which is one of its more criticized flaws. So Peter came up with this original idea of the flow model pattern back in 2013 to solve some problems that he could not resolve with page object approach. In this approach, the structure of the application is separated from the logic. All the user flows are stored in these separated flow models, creating a facade over the page objects. Now Peter is going to present how flow models differ from page object models and tell us the basics through showing examples as well. So Peter, the stage is yours. Welcome.
Thank you very much, Yuri, and yeah, thanks for first of all the invitation to this event, and I'm really happy to be here speaking for the audience. And yeah, let me share my screen, and I'm pretty sure that everybody will appreciate that. So just a moment, and yeah. Okay, and very, very soon you should be able to see it. Okay. Let me know once you can see it, but I assume you should be.
Not yet. Okay, we can see it.
Okay, great. Thanks. So, okay, again, thank you very much for joining this session. And actually, I can still hear some voices. So if all of you could please mute yourself, I would appreciate it. Thank you very much. Okay, so as you mentioned, so I'm Peter Foldhazi Jr., and I'm a Hungarian currently residing in the United States. And I started working as a tester 15 years ago, exactly 15 years ago. And I started working for EPAM 9.5 years ago as a tester, and right away I moved into test automation. And for a very long time, I was a test automation engineer. And recently, I moved into consultancy. So I'm basically working as a quality architect on different projects for numerous clients. And so I'm going to be talking about the flow model and the page object and other design patterns. And you will very soon you will see why I'm talking about those, and that's because the page object pattern is something, as mentioned before, that most of the test automation engineers hopefully already know and hopefully already use as well if they are doing UI test automation. And so the flow model pattern is building on the page object pattern, but I will talk about only after I gave some insights to page objects and to design patterns in general. And that said, let me start with the first topic, design patterns, which probably will ring a bell for some of you, hopefully for more of you. And this is actually when we talk about design patterns, most of the time people are thinking about the gang of four design patterns. And this is something that is very important for developers. And as test automation is development work as well, it's very important for us test automation engineers as well. And actually in EPAM for senior and of course lead test automation engineers, we require that these engineers know or have heard about at least the gang of four design patterns and have used some of those patterns. Of course, you don't have to know all the 23 design patterns by heart. So what they provide is basically solutions to common software design problems, and something that others have already faced, something that you have faced numerous times, and you're going to be using the same patterns to resolve those problems. And my personal favorite out of those 23 patterns is the facet pattern. And one of the main reasons is because it's very easy to use in test automation, and actually many of the test automation specific design patterns are building on the facet pattern. And so what it does is basically it wraps a poorly designed collection of APIs, and it's just exposing these for you to be able to reuse them. You don't really need to know what's the underlying code. You might, and maybe you built it yourself, but when you are using it, you don't really care about how it's implemented. You only care about using that service. That's exactly what we are doing in testing as well, in test automation. And as I mentioned, test automation specific design patterns are building on the facet pattern. And the first one, which really got widespread and actually the most known in the world, is the page objects, which was invented by Simon Stewart and his colleagues early in the 2000s. And it is focusing on organizing your pages. But I'm going to go into more details with that a little bit later. What's very important to know about the page object, I think, is that it's focusing on the UI, on pages, and so it is leverageable in UI test automation. And as it's so popular and so useful, when you go to into EPAM, and I'm guessing to other companies interviews as well, it's very important to know the page object. So make sure to listen to that part as well, do your researches, and start using it if you haven't already, because I'm pretty sure that that in case you want to go for an interview or get promoted at your company, and if there's an assessment, promotional assessment there, then it's going to be a topic that will be brought up. Now, stepping forward, the screenplay pattern was invented by Anthony Marsano and his colleagues. They are the ones who are working on the Serenity BDD, so that's where it's leveraged. And instead of focusing on organizing the pages, now it's focusing more on organizing the users and addresses some of the issues that people had with the page object. And the flow of the pattern is going to be the main topic today. So I invented it 8 years ago, actually almost 9 years ago, because it was at the beginning of 2013. And so instead of focusing on the pages, users, it focuses on user actions. And the last one, but not least, is the UI objects, which was invented by Ron Yevlev, who is also an EPAMer, and just a year or two after the flow model was invented. And that one, instead of focusing on how to organize the pages, it's focusing on how to operate the pages. So you can see that some of these patterns could actually even be combined, but let's not get into that right now. So I just wanted to show how they look like in high level, and I think it's good to make some researches on these design patterns. So let me start with the page objects. So when you look at this piece of code, then the first thing that comes to your mind is probably that, okay, what is going on here? So what's this test script is about? Is it even a test script? Or what? Actually, it is. It's an Android test script. And so if you don't know the class file name, then probably you don't know right away what this is about. You see that there's login, and then you later on, as you start looking at more lines, you will eventually figure out that, okay, this is a login scenario and a successful one. So what is the issue with this kind of unstructured scripting? The issue is that whenever you want to maintain this kind of solution, or you have someone new on the project, and especially someone who is a junior test automation engineer, it's going to take a while for them to understand all these scripts and be able to maintain them. Now imagine if there are only 10 such test cases. It's not a big issue to maintain them. You can already feel the differences, but it's okay. And for POCs, proof of concepts, it's actually okay to use such kind of approach because you're not focusing on making it maintainable. You're focusing on proving a concept. For example, can you do test automation on your project? Or there are two tools or frameworks. You want to compare them. How do they compare to each other? You're not caring about the test script itself. You're caring about the tool, the underlying tools. How do they measure to each other? But when you want to do real test automation on your project, that's when you're going to have a couple of dozens of test cases, maybe a couple of hundreds or even thousands of test cases. Now imagine you have over 1,000 of similar test cases on your project. Even if there are 5 or 10 test automation engineers on your project, it's going to be a nightmare to maintain it. And many times we are happy if there's even one test automation or 2 test automation engineer on the project. Okay, so that's exactly how I look like when I see people telling me that they are following this approach and are trying to achieve several hundreds or even thousands of test cases on their project. It's not going to work, buddy. So that is exactly what the page object is addressing here. And now we are talking about just the UI test automation. So no API, no end-to-end with API and DB testing, just UI test automation. So what is the page object exactly? So when we are talking about page object, it's page object modeling. So you're basically creating a class file for each of the pages that you're going to interact with. And it's basically you're modeling your screens or pages. And for each of these class files, you're going to have locators, web elements, user actions, or even more complex user scenarios, kind of user flows. And so you're going to store everything there, everything that is related to that given page or widget. And you can have images, buttons. It's very important that you should only store elements and actions that you're actually going to use in your test cases. And so once people started using the page object, they were able to make the code much more readable, and maintainable. More to that later, so I'm going to give you some examples later, but this is a very, very useful and very important design pattern for us test automation engineers. So to tell you a little bit more about the history of the page object, and I think it's a really fascinating. So when I first created, well, the first version I created for this presentation was somewhere in 2013 or 14, just a moment. And when I created this version of the flow model pattern presentation this year for the Star East conference for April, then I actually reached out to Michael Pelotash, who talked on the same conference that I did back in 2016 on the Hungarian Software Testing Forum. He was a keynote speaker and tutorial speaker on that conference, and his topics were revolving around Selenium. And I knew that he and his team were contributing to the Selenium project. And so I asked him, okay, can you tell me about the history of the page objects, overall Selenium? And unfortunately, a lot of the information on the internet that I previously could find like 9 years ago, I couldn't find them anymore. So he was very nice and connected me to Simon Stewart, who is basically the father of page objects, and he's still leader of the Selenium project. And they recently released Selenium 4. So I had some emails back and forth with Simon, and he was really nice and shared a lot of information for me to be able to use in this presentation. And so basically, the idea came at the beginning of the early 2000s. They were struggling with UI test automation with some typical problems. So that's how design patterns are created. So you have some typical problems, and you have a solution, and you can use that every time you're doing test automation, right? And that's how the WebDriver and the page objects were born. And he basically, the first time he publicly spoke was in 2007. And so he works at ThoughtWorks, and that's where Martin Fowler works as well. And he was the one who basically came up with the window driver pattern, which was the predecessor of the WebDriver and the page objects. And they were leveraging the try principle and the facet pattern as well, just as I mentioned. So facet pattern is really useful in test automation. So going onwards, as I mentioned before, and you mentioned as well in the introduction, some people believe that the page objects are breaking some of the principles, solid principles, and other principles as well. I don't fully agree with these people. I actually agree about the single responsibility part, more to that very soon. About the open closed, I don't agree, because basically when you are executing your tests, you're going to wait for the results to come in. Once they came in, you do your analysis, and then if necessary, you're going to make changes in your code. If there's a new element that you need to test, there's a task flow that changed, or there's a task that you have to completely get rid of, then you're going to do that after you executed all of your test cases. That's the typical thing. Of course, you can do it on the fly, but I don't think too many people are doing that. Okay, so because of that, I don't really think that page objects actually is against the open closed. I don't think that's a concern. Another one that people are mentioning is the YAGNI principle. So you're not going to need it a principle. And actually, again, I don't think it's the page objects that is breaking that principle. It's the human beings who are leveraging the page objects in their projects. So if you're designing your test cases correctly, your page models correctly, you're going to use only the ones that you actually need. So it's not the page objects, it's us. So if you don't design your test cases properly, of course, then you're going to break the YAGNI. It's not the page objects. So let me go into some more details about the single responsibility, so that you can understand why the page object is breaking it. So on the left side, you can see a bunch of shapes, and on the right side as well. But on the left side, these shapes are all over each other. And on the right side, they are quite tidy, they are orderly, and they are separate. So on the left side, that's representing a class file which includes all sorts of different shapes. So let's say that I want to change the triangle, or change something in the triangle. And when I do that, I go into this very same class file where I have a rectangular and a circle as well. So when I'm making a change in the triangle, it might be if I did some mistake in designing this class file, I might make a change in the other shapes as well, not just in the triangle. And to make sure that such a mistake doesn't happen, one of the things that we can do is separating the concerns, separating these three shapes into three different class files. And now, whenever I make a change in the triangle, I'm only going to affect that class file and that functionality, not the other two. So that's good. And so this responsibility was the single responsibility was invented by Uncle Bob, and he said that, well, it's originally coming from many other principles, and for example, the separation of concerns. But he was the first one to really articulate it and why it's important, and how we should be doing it. And a lot of people were asking him, okay, hey, Bob, so can you tell us what is the reason for a change? How can I determine what needs to be, how do I need to be separating my class files? And basically, each class file should have only one reason for change. But how can you determine that? And later on, after a couple of years, he figured out that basically the reason of change comes from people. So either from one person or a group of people. And when we think about the responsibilities of the page objects, you can see locators, elements, actions, and user flows. So I will give you 30 seconds, and let me let me actually count the 30 seconds. Just a moment. I will give you 30 seconds, and please think about it. Who do you think are responsible for locators, elements, actions, and user flows? And write it down in the comments. I'm really interested in hearing that. So I give you 30 seconds. All right. I hope that this was enough time for you to think it over and write down in the comments as well. So let me give you my version, and let's see what you think about it. So in my opinion, the reason for change for locators and elements come from developers. And the reason is because the developers are the ones who are building the application, right? So whatever changes they make to the DOM is going to affect the locators. It has elements as well. So the reason for change is the developers there. For actions and user flows, there might be a little bit of debate. So it could come from the business directly, or directly from testers, or from both type of people, or both roles. I think in most cases, it's the testers, and I believe it should be the testers who are providing the actions and the user flows. But of course, I'm happy to debate it, so let me know what you think and whether you agree or disagree with me. That said, the page objects are breaking this responsibility of single responsibility, and so there are at least two reasons for change in a page object model. Okay, let me move on and to summarize it. So basically, a lot of people think that the page objects are breaking the open closed and the Yagni principle. I don't think it's necessarily a concern. The single responsibility part is a concern though, so breaking that is of course not nice, and that's why the flow. Well, that's not necessarily why the flow model pattern was created, but it's definitely addressing it, and some of the other patterns were born for the same reason. And just an added note, so the page factory, which a lot of test automation engineers are actually mentioning in interviews or when we are having engineering discussions, it's very important that the page factory is not recommended anymore by some institute and his team. For like, it hasn't been recommended for several years now, and I'm still hearing people mentioning it in interviews. So please make your research on YouTube. You can find a YouTube video with Simon where he talks about and why he doesn't recommend it. That's not the page object pattern, but it's very closely related because people are using it for generating their or populating their web elements. Okay. Anyway, let me go on to the next topic and our main topic for today, and that's the flow model pattern. And first, I'm going to be talking about how it can be leveraged in UI test automation. So on the left side, you can see a house with one facet over it, which is hovering over the pages, widgets, user actions, and user flows. That's how I can describe the page object pattern for you. On the right side, you can see a house with a facet over other facets. And basically, the user actions and user flows are above the pages and widgets. Why is that? It's because the user actions and user flows are referencing to elements of the pages and widgets, right? So they're going to leverage that. I'm going to show that later in a coding example how that looks like. So this is how I can describe the differences between the two patterns. Now, going onwards, let me give you a general example of a state machine diagram, because when I first tried to tell people how to design flow models, this is what I thought of, that actually it looks exactly the same as a UML state machine diagram. And let me show you how. So let's say that you would like to get a drink from a soda machine. So you have a list of drinks, you're going to make a selection. So there are states and there are transitions. With the selection of the drink, you get to another state, to the payment. So now you insert your card, you're automatically going to get the portion of the money that you have to pay for that drink, and then you get to the confirmation page or UI, and then you get your drink as well, and you can enjoy your soda. So that's how the state machine diagram looks like. Now, how does the flow model look like? The flow model, you can see that now, instead of just having one model, a page model for each page having one model, now you still have those models for the pages, but now it got separated. So the structure itself is still there in the screen models, or page models, whatever you want to call them, depending whether it's a web UI or mobile UI application test automation. And the flow models are a separate model which actually are storing the logic of the application. Very important. The structure of the application is in the page models and screen models. and the logic, what actions you can do, are in the flow models. So you can get from the main screen to the login screen by clicking on the login button. If you type your credentials, you're still staying on the login screen, so there's no transition to another state. You're just going to be idling on it. And then once you click on the continue button or login button, whatever you call that, you land on the profile screen. You can validate whether you got actually landed there and with the right account. You can make edits or use the application from there. And once you click logout, you get back to the main screen. So it's a very simple flow model here. And of course, you can make it a little bit more complex by leveraging widgets. What are widgets? So widgets are parts of screens, especially on web, you can see, but even on mobiles as well, such as the toolbar or menu bar. So these are elements that are visible on not just one page, but on numerous different pages. And of course, they are not, even if they are embedded to that given page, they are embedded to other, like multiple different pages as well. So you cannot just say that, okay, it's part of that page, because it's not part of just that page, it's part of other models as well. So now you're going to make a separate model for that widget. Whenever you are on a page where it's visible, you will be able to reach that by instantiating that widget. So that's how it looks like. And so again, it's a little bit more complex, but it's still a relatively simple example for a flow model. And I would like to show you an example, a coding example, but first let me show you. So I'm leveraging a tri-layer architecture where I have test cases, all the business logic in the middle layer, flow models and structure models. That's where you would normally have them, and any other application dependent class files. The last one is basically the common libraries, project or non-project common libraries that you can leverage, base tests, base pages. Okay, so why I show it is what I already mentioned, is that the flow models and structure models are typically in the business layer because they are holding application dependent logic. This is something that I'm talking actually in another presentation of mine, the tri-layer testing architecture. So I'm not going to be going into more details because I only have around roughly 15 more minutes to the flow model, and I actually want to show you some very exciting examples. So leveraging this tri-layer concept, here you can see a design where I have a base screen, user action, and base flow, and I have my page models, or more like structure models, home screen, the widgets, and other screens. And in this example, I only have one login flow, but of course you can have more complex scenarios with multiple flows, but this is just going to be a successful login scenario. So the login flow is basically going to reference to these pages and widgets, and it's going to hide that piece of code from the login test, because in the test, I don't necessarily want to see how the locators or web elements look like, which one I'm referring to. I don't really care. I just want to make an action. I know, of course, which page I'm on, or I should be, but that's not the biggest. That's not the most important here, but the actual flow. But I'm going to show that a little bit later. So this is an example here that I'm pretty sure you remember from the beginning of this presentation, the one that where I talked about POCs, that it's okay for POCs, but not for real professional bigger test automation projects. So here you aren't leveraging any of the page models nor flow models. So it's in the long run, it's impossible to maintain such a solution. And if there's a project newcomer, especially juniors, it's going to be a nightmare for them to to learn how to use this test automation framework and maintain the test cases. So as a first step, and what I do when I write my first test script, just like in the previous slide, after that, I'm going to make all the necessary page models, and I'm going to move all the elements there that I'm going to interact with. And so what this gives to me is now I'm able to reference to these elements in my flow models, and whenever I need to make a change in the structure, let's say the structure of the application changed, that's new element, or maybe there's a password which was just a regular text box before. You could see the actual typed in password. Now it's a secured edit box, and you only see stars or little dots instead of your characters. So there's such a change. Now you have to change that element. You will be able to do that here. So this is how the test itself looks like after leveraging screen models. And so this is already much better than what we had before. Now we know where we are. Now we know that we are going to interact with the toolbar and the layout drawer of the toolbar, then which is basically going to be the menu button, the hamburger menu. Then you are going to click on the login button in the menu, and so on and so on. So you know where you are. That's a good thing. But it's a little bit more difficult to still really know what is going to happen. You know that you're doing click actions and all and typing, but it still takes a little bit more time compared to when you're leveraging flow models. So in the flow models, you can have simple user actions and more complex user scenarios. And now how it looks like is that this exactly resembles to how test cases should look like. There are actions, and that's what really matters for you, because you are going to generate test cases according to what users are doing, right? So it's and that's the big thing here. In the page objects, you're focusing more on the structure of the application. So that's what is driving your models. Here in the login flow, the tester, and not just the tester, but the user is driving the tests now, and not just tests, but the models themselves. And that's what really matters for us. What is the user going to do? How can the user break the application? I want to know that. I want to test that. That's what I want to test every time I'm going to run my regression suit. So once I do that that change, and now I'm leveraging flow models as well, this is how my test case is going to look like. So I'm hiding all the information about where I am, and I only expose what I do. And that's what is going to be reflected in the test cases. And let me compare it to you. So first, the unstructured version, where you have a lot of test steps, and this is a very simple scenario, and still we have over 1,000, probably 15 lines of code, and maybe even more. And leveraging the page model is already going to make it more readable and maintainable. But if you look at the one with the flow model, of course, I find it much better and easier, but please let me know what you think and what is your opinion. But I think this version is even tidier, even easier to understand, and that's what I've been experiencing in the past on all the projects where I was leveraging it and where I was mentoring colleagues to start using it. And that's what I've seen, that basically you know that you're going through a login scenario. You know exactly what's happening here. And it's very important that here I was focusing only what's happening. Of course, there's more to that. So you can even start adding more to that. And instead of exposing like Darth Vader and I'm your father, the credentials of the users, you can move that out. But that's, again, a different topic, and that's very important as well. And that with that, you can make it even better, even even a neater test case. Basically, you're creating a facet over all these facets and hiding the implementation details, and it's going to be more abstract and easier to maintain in the long run. Okay, and how can we leverage that in API testing and end-to-end testing? So now this is another big thing compared to the page objects. Page objects is focusing on the UI. And originally the flow model pattern, I was leveraging it in UI test automation. But later on, when I worked for a client that is providing bank cards, basically all over the world for hundreds of millions, maybe billions of people. And so, of course, they have very, very complex scenarios. And we only had to just test a little portion of that. And that was already like really huge. And some of the test cases were like hundreds of test steps. And it's really, really a crazy amount of things going on in the back. And we wanted to simplify them, and we wanted to make sure that we can reuse them in all sorts of different testing. And so what came to my mind, maybe I could leverage the flow model there as well. So the big difference compared to UI is, so before we had structure models. Now for API, you have utility classes, and not just for API, actually. I'm going to talk about it a little bit more. So let me give you one example. So let's say that you are a card holder, and or when you want to test that someone is a card holder, and so there might be a potential fraud. You suspend that card, then it turns out that that there's no fraud, so it needs to be unsuspended and see whether it's still working or not. So here, what you're going to do is you're going to have all sorts of different APIs, account API, suspend, transaction, unsuspend, and of course, again, you want to check whether you can do the transaction or not. Let me show you the coding example for that. So now here you can see that I'm using multiple flow models. Before I only leveraged a login flow, here multiple different flows. And basically, first, I just want to make sure that I'm using the right account. Then with that account, I would like to make a suspension, or to that account, I would like to make a suspension to that person's card. And then I would like to validate whether I suspended it correctly or not. Then I would like to check if I'm able to do a transaction. Again, it's a validation, to be honest. But I actually need to make that transaction call and validate whether it's really not going through because of my card being suspended. Then I unsuspend my card, validate the unsuspension, try to make a valid transaction and validate whether the transaction went through or not, and see whether my account, there was a change in my account, the balance on my account. Okay, now this looks again very simple. If you look at it, you know exactly what's going on. You know the flaws. That's, as a tester, that's what you really care about. Of course, the underlying coding is much more complex. And just to give you some examples, so, and this is again something that you can do in the flow model because of using facets, is that validate suspension actually, at least for different validations, you want to check whether the response code is the one that you're expecting. The body itself, is it the same what you're expecting? You can make database validations, Splunk validations, all sorts of other validations, depending on what internal systems you have or what reporting, logging, or whatever tool you are leveraging. And so that said, and well, I only have 1 more minute as I see, so it's perfect. So basically, the flow model is addressing the single responsibility issue with the page object pattern, and it's leveraging the facet pattern just like the page object, because it's basically built on that concept, and it's basically a natural evolution of that. And so because it's actually leveraging double facets, it's even more even easier to ramp up newcomers to the project. And the maintenance costs are again even furthermore lowered because now the user actions and complex user scenarios are also under facades, and it's so much easier to maintain them in the long run, especially if you have hundreds or thousands of test cases. And another big pro to this pattern is that it can be leveraged not just in UI, but in end-to-end testing and in some sorts of API testing, not just end-to-end, but some more complex API testing as well, not necessarily in with atomic test cases. There doesn't really make sense to leverage flow models, but in more complex scenarios, it does. The big con for this one is actually that it's experience based. So my experience is that when someone starts on a project where I'm leveraging the flow models, for them understanding the concept is not a big issue. Start using it again, it's not a big issue. The issue comes if it's a developer, for example, who doesn't necessarily have an experience in test case design. Now for them, creating flow models is going to be a little bit more difficult. And also for people who are completely new to that domain or to that client or project, they need to understand the product itself or the underlying APIs. And it's a lot of work, so they need to learn that. And many times what I recommend is just do some manual testing if that's possible. Learn the product, learn how you can test it. And once you did, then it's going to be easier, much easier to build flow models. Okay, that said, I would like to thank you for listening to my presentation, and I hope that you enjoyed it and that you learned something that you will be able to leverage in your daily work. And please let me know in the comments or on LinkedIn or Twitter what you thought about this presentation. And in case in the future you are going to leverage it in your project, I'm really happy to hear about it because I would like to spread the word as much as possible. And yeah, you can see some of my other videos as well on YouTube. So feel free to look up Peter Foldhazi on YouTube. You might be seeing me or my father. He's not a software engineer, but you might see some videos of him as well. And so my references, so a lot of people helped me during these 8 years to evolve a flow model and this presentation, and especially this last version. And you can see some links over here, so we will definitely share them with you so that it's going to be easier for you to see some of the videos as well, which are really, really useful. And these are the pictures that I used during the presentation, so I took them myself. So one of my goals here in the US was to go to a lot of places that I really loved as a child, and I took some photos. I hope that you enjoyed them as well. Again, thank you very much. And if you have any questions, please let me know.
Thank you, Peter. It was amazing speech. As I can see, we actually do not have some questions, but we have some comments from Dmitro. He put the comment about unstructured piece of code when you were presenting that is hardly to support. Would you like to comment on this comment? Well, it's
It's hard to support such a type of code. That's what Dimitri means, I guess.
Mm-hmm.
Oh, absolutely. That was my point. Let me just find it, but just a moment, because well, it's easier if I go here. Yeah, absolutely. So that's the main point here. That even I think 10 test cases can be painful to support some just 10 test cases with this approach. If you have 100 test cases or hundreds of test cases, which is very much like a reality in many of our projects, no, it's not going to happen. You're not going to get there. So yeah, absolutely agree with you.
Yeah, and well, one more comment from Sergey. Sergey wrote that it appears that he has been using the flow model without knowing its name. So it's
Nice.
very useful, and everybody is encouraged to use it.
Yeah, I'm really glad to hear about it. And actually, I think so. Even though I came up with this idea in 2013, and I articulated it in a presentation a year later in the Hungarian Software Testing Forum. So I believe I'm the first one actually. All this researches that I made, I haven't really seen anything, or actually I didn't find anything on the internet that was close to the flow model. Even though I articulated it first, I'm pretty sure I'm not the only one, as you can see. So Sergey also came up with this idea and started using it. I'm pretty sure that there are some more other people as well out there who started using it because it makes sense. So it's actually a very simple concept and just a natural evolution of the page objects. That's how I see it.
Okay, as I can see, we're done with this topic, and I'd like to remind you that we have one more great upcoming topic, and it's about how to protect against DDoS attacks, proactive and reactive modes, and presenters are Kakha, Chkhartishvili, and Pavel, Kuwchinow. I'd like to add a few words about our speakers. Kakha Chkhartishvili is information security system engineer from EPAM, Georgia, with solid networking and telecommunication background, skilled in multi-vendor technology solutions, experienced as the subject matter expert and exam developer. Kakha leads many trainings on information security and networking. And Pavel Kuwchinow is a senior security testing engineer from EPAM, Poland. He has a strong technical background in addition to commercial experience in vulnerability assessments of various platforms such as web, mobile platforms, or IoT devices. Pavel is constantly involved in various types of public cybersecurity challenges. Wow, that's interesting, I guess. He has solid experience in developing and iterating security test automation tools. All of this helps him to constantly research and analyze known hacking methodologies, identify new exploits and vulnerabilities. So let's dive deeper into our topic. And DDoS attacks are old, but still one of the most powerful attacks used by cyber criminals on the internet. Such attacks are used to make easy money or as a method to protest official agencies or corporations. Often DDoS attacks are just a cover for more sophisticated attacks. The response to those threats is the evolution and development of tools and techniques of threaten against DDoS attacks. As a part of this presentation is the review of what DDoS attacks are, what types they are divided into, what is used to carry out DDoS attacks, and how it can be amplified. Along with this, it will be presented what can be done to protect or minimize the consequences of DDoS attacks. What actions are recommended for use in various stages of DDoS attacks, such as preparing for a potential DDoS attack, detection, and possible protection. So, Pavel and Kakha, stage is yours. Welcome.
Thank you very much. So I guess you hear me?
Yes.
So thank you very much, Yuri. Thank you, Peter, for your great presentation. Let's go with our part. So as you can see, once again, our presentation will be related to the DOS attack and called how to protect against the DOS attacks. And we will describe proactive and reactive modes. Once again, the agenda, we will go through the different topics like what is denial of service, what is the difference between DOS and DDoS attacks, how the DDoS attacks works, and we will describe few scenarios, and also if everything will go smoothly, we will show you a demo. on how the DDoS attacks works in life and how the environment can be protected against it. So let's start. So the DOS attack, it's a process of the flooding the target with traffic or sending information that triggers a crash. In both instances, the DOS attack deprives legitimate users of the services or resources they expected. Victims of DOS attacks are often target web servers of high-profile organizations such as banking, commerce organizations, and media companies. Tough DOS attacks do not typically result of the theft or loss of significant information or other assets. They can cause the victim a great deal of time and money to handle. So the difference between regular distributed denial of service attacks are substantive. In the DOS attack, the attacker uses a single internet connection, either exploit a software vulnerability on or flood a target with fake request, usually in attempt to host the server resources. For example, it can be a CPU or memory or other resources, which is service depends on. On other hand, distributed denial of service DDoS attack are launched from multiple connected devices, and they're distributed across the internet. These multi-person, multi-devices attacks are generally harder to deflect, mostly due to a huge volume of devices involved. DOS represents a system-on-system kind of attack, but DDoS uses multiple system against a single one. DOS attacks also differ in the manner of their execution. Broadly speaking, denial of service attacks are launched using homebrew script or DOS tools, for example, like low orbit ion cannon, Hulk, or HPing, while DDoS attacks are launched from botnets, large cluster of connected devices. For example, it can be cell phones, PCs, routers, infected with different malware that allows remotely controlled by attacker. So how the DOS attacks works, we might see the internet of cyberspace, a cyberspace of infinite possibilities. Web service and channels that connected to those internet resources and other network resources have a finite, limited number of requests and capacity. If these numbers are exceeded, usually by the hand of malicious actors, the responses of the request that legitimate users launch will be much slower, and the requests themselves might be totally bypassed, which actually represent the goal of denial of service attacker. Speaking of attacker goals, they DDoS for a variety of reasons. For example, to discredit a business, it may be competitors, to ask for the payment before stopping the attack, almost like ransomware offenders. Such attacks can affect customer experience. For example, since the customers might not be able to access your company website or mobile application, affect the revenue because retail sites or apps downtime will make purchases impossible. Affect the workflow because DDoS attacks will leave employees unable to access the email and the other online resources they need to get their work done. Affect your brand reputation because customers and business partners might think twice before connecting with you if you cannot ensure your business security. So we mentioned about the botnet. So what is it? A botnet is a collection of hijacked connected devices used for cyber attacks that are controlled remotely with some kind of control center. These typically include personal computers, mobile phones, unsecure IoT devices, and even resources from public cloud services. Attackers use malware or other techniques to compromise a device, turning them into a zombie. And the botnet enable attackers to carry out DDoS attacks by harnessing the power of many machines on obscuring the source of the traffic. Since traffic is distributed, it's difficult for security tools and teams to detect that kind of DDoS attacks until it's not too late. And we will go through the types of DOS attacks. We have usually two types of DOS attacks, and the first category, includes two different types of DOS attacks. First one, it's a volumetric attacks. The classical type DDoS attacks. These attacks employ methods to generate massive volumes of traffic to completely saturate bandwidth, creating a traffic jam that makes it impossible for legitimate traffic to flow into our site. And protocol attacks are designed to eat up processing capacity of network infrastructure resources like servers, firewalls, and load balancers by targeting communications with malicious connection requests. And the second category, it's more sophisticated DDoS attacks, which exploit weaknesses in the application layer by opening connections and initiating a process and transaction request that consumes finite resources like disk space and available memory. Let's review DNS amplification attack as very popular attack nowadays. So the mainly amplification attack is an attack that used to magnify the bandwidth that is sent to a victim. Just a high level of how DNS works. When a user types some site.com into their browser, DNS is internet service that accepts that requests, finds the appropriate IP address assigned to that domain name, and set it back to the browser so the client can connect to the website. But attackers can craft DNS request in a way that amplifies the size of the response. As example, by requesting not just the IP address, but information about the entire domain. So the response might include details about subdomains, backup servers, mail services, aliases, and many, many more. And suddenly a 10-byte DNS request could generate a response that in 2 or even in 5 times larger. But what is wrong on this picture? The DNS response are being sent back to the attacker, not to the intended victim. Attacker can spoof the source IP address to the victim's one. This strategy both hides the attacker identity and ensures that all responses from the DNS resolver will send to the victim system instead of attackers. And remember, DNS relies on UDP since it's fast because its primary job to relay messages back and destination and does not care about what is guaranteed delivery or validating the data. In this way, the DNS resolvers are acting as reflectors, returning responses to a victim that never requests anything. And finally, attackers will send multiple DNS queries and likely will use multiple DNS resolvers to carry out this attack. A little bit of history of DOS and DDoS attacks. Probably the first ever DOS attack was executed by David Dennis, a student at the University of Illinois High School. In 1974, he successfully managed to shut down 31 Plato terminals by writing a program that sent a problematic command. It was done as an experiment, but the principles would soon be applied for more odious reasons. In 1996, New York-based internet service provider Panix became the target of DDoS attack. The hacker used a spoofed IP address to overwhelm the company's servers with fake synchronized packages, forcing it to stop processing actual requests. And Panix managed to recover it around 36 hours. But this event was significant for being one of the first major DDoS attacks. Perhaps the most famous DDoS attacker is Mafia Boy, Michael Kaltz. In February 2000, he launched a massive DDoS attack targeting major corporations such as CNN, Yahoo, Amazon, and Dell. And this guy used a tool called TFN2 that makes use of previously infected computers to generate a huge amount of fake traffic to a server. In order to stay undetected, the tool also featured with encryption utilized by standard network communication protocol. Also, on August 2021 was observed a 2.4 terabytes DDoS attack targeting the Asia customers in Europe. In 2020, Google's security reliability engineering team measured record-breaking UDP amplification attack sources out of several ISPs around the world. The main part of these ISPs was located in China, and they attacked of thousands of Google IPs addresses, and lasted for 6 months and peaked at 2.5 terabytes per second. AWS was hit by a DDoS attack in February 2020. This was the most extreme DDoS attack ever and targeted an unified AWS customers using a technique called connectionless lightweight directory access protocol reflection. This technique relies on vulnerable third-party components and amplifies the amount of data sent to the victim's IP address by up to 70 times. The attack lasted for 3 days and peaked at 2.3 terabytes per second. In February 2018, GitHub was hit with a DDoS attack that clocked in at 1.3 terabytes per second and lasted for roughly 20 minutes. And on September 2016, the blog of cybersecurity expert Brian Krebs was assaulted by DDoS attack and access to 600 gigabytes per second. Krebs had recorded more than 200 DDoS attacks previously, but this attack was almost 3 times bigger than anything his site or the internet had seen before. The resource of this attack was the Mirai botnet, which were consisted of more than 600,000 compromised IoT devices. The Mirai botnet had been discovered in August the same year, but the attack on Krebs' blog was the first big outing of this botnet. So let's review the attacker motivations. So hacktivists, these persons are using those attacks as a means of express their criticism of everything, from government and politicians, including big businesses and current events. Cyber vandals are often referred to as script kiddies for their reliance on pre-made scripts. These vandals are often teenagers looking for adrenaline rush or seeking to vent their anger or frustrations against the institution, for example, school, or person they feel has wronged them. Extortion, an increasingly popular motivation for DDoS attacks, meaning a cyber criminal demands money in exchange for stopping DDoS attack. Business competitions. DDoS attacks are increasingly being used as a competitive business tool. Some of these assaults are designed to keep competitors from participating in different events, for example, Cyber Monday, Black Friday, or Christmas selling events. Cyber warfare. State-sponsored DDoS attacks are being used to silence government criticism and internal opposition. And of course, personal contents, when those attacks can be used to settle personal scores or to disrupt online competitions. So that's it from my side. Now I'm going to give a word to my colleague Kakha, and see you soon.
Thank you, Pavel. So I will continue now. We don't need the presentation for me because Yuri already presented me. So can we follow the next slide, please? Okay, how to mitigate DDoS attacks. The first, you can prevent, first of all, how to mitigate the DDoS attacks, right? You can prevent those assaults. Cyber criminals are going to attack. Some are going to hit their targets regardless of their defenses in places. However, there are a few preventive measures you can take on your own. First, monitoring your traffic to look for abnormalities, including unexplained traffic spikes and visits from suspect IP address and geolocations. All of these could be signs of attackers performing dry runs, so-called dry runs, to test your defenses before committing to a full-fledged attack. Recognizing this, what they are, can help you prepare for the onslaught to follow. Second is keep an eye on social media for threats, conversations, and boats that may hint on an incoming attack. Third one is consider using third-party DDoS testing. For example, pen testing, penetration testing, right? To simulate an attack against your IT infrastructure so you can be prepared when the moment of truth arrives. When you undertake this, test against a wide variety of attacks, not just those which you're familiar with. And the last one, I think, is create a response plan by all means, and a rapid response team to organize it, meaning a designated group of people whose job is to minimize the impact of an assault. When you plan, put in place procedures for your customer support and communication teams, not just for your IT professionals as usual. The first step in selecting a DDoS mitigation solution is to assess your risk. Important basic questions include which infrastructure assets need protection, what are the soft spots or single points of failure, or what is required to take them down, or how and when will you know you are targeted? Will it be too late or no? What are the impacts, financial and otherwise, of an extended outage? Armed with this information, it's time to prioritize your concerns, examining various DDoS mitigation options within your framework of your security budget. Second step is to choose the method of deployment. The most common and effective way to deploy on-demand DDoS protection for your core infrastructure services across an entire subnet is via a BGP protocol, which is a border gateway protocol. However, this will only work on demand, requiring you to manually activate the security solution in case of an attack. Consequently, if you are in need of always-on DDoS protection for your web applications, you should use DNS redirection, domain name service redirection, to reroute all website traffic as HTTP, or it might be HTTPS, through your DDoS protection provider's network, usually integrated with a content delivery network, so-called CDNs. The advantage of this solution is that most CDNs offer on-call scalability to absorb volumetric type of attacks, at the same time minimizing latency and accelerating content delivery. Next slide, please. Yeah, thank you. Dealing with network layer attacks requires additional scalability beyond what your own network can offer. Consequently, in the event of an assault, a BGP announcement is made to ensure that all incoming traffic is routed through a set of scrubbing centers. Each of these scrubbing centers has the capacity to process hundreds of gigabits worth of traffic. Powerful servers located in the scrubbing centers will then filter out malicious packets, only forwarding the clean traffic to the origin service through a GRE tunnel, for example, which is generic routing encapsulation. This method of mitigation provides protection against direct-to-IP attacks and is usually compatible with all types of infrastructure and communication protocols like UDP or SMTP, FTP, or it might be voice over IP protocol, and so on and so on. The second step is mitigation of application layer attacks relies on traffic profiling solutions that can scale on demand, while also being able to distinguish between malicious bots and legitimate website visitors. For traffic profiling, best practices call for signature-based and behavior-based heuristics combined with IP reputation, scoring, and progressive use of security challenges, for example, JS or cookie challenges. The mitigation stages are detection, which is an identification of traffic flow deviations that may signal the buildup of a DDoS assault. Effectiveness is measured by your ability to recognize an attack as early as possible, which instantaneous detection being the ultimate goal. Second one is diversion. Traffic in this case is rerouted away from its target via DNS, so I already mentioned about this, domain name system, or BGP border gateway protocol routing, and the decision is made whether to filter it or discard it altogether. DNS routing is always on, so it can respond to attacks quickly and is effective against both application layer and network type layer attacks. BGP routing is either always on or on demand. Third one is filtering. DDoS traffic is weeded out, usually by identifying patterns that instantly distinguish between legitimate traffic, for example, humans, as always, API calls and search engine bots, and malicious visitors. Responsiveness is a function of your being able to block an attack without interfering with your user's experience. The aim is for your solution to be completely transparent to site visitors. And the fourth and last step, I think it's an analysis. It's a system logs and analytics can help gather information about the attack, both to identify the offender and to improve future resilience. Logging is a legacy approach which can provide insights, but it's not real-time and require detailed manual analysis. Advanced security analytic techniques can offer granular visibility into the attack traffic and instant understanding of attack details. There are a lot of vendors who provide DDoS protection mechanisms for clouds and on-premises, and they differ free and paying, and there are several reasons not to list them all, for sure, because they differ with their technology concepts and problem-solving approaches. But I want to mention a few of them, as they are leaders and they can provide services which are definitely in high quality. And first of all, it's an Imperva. I think the Cloudflare is also quite good solution. Radware, AKMI, and all the cloud solutions like AWS or Microsoft Azure, AWS Shield, I mean, but generally you can use so many services to protect from this type of attacks, as it is a DDoS attacks. So generally, as I mentioned already, there are quite a bunch of service providers who are providing this type of solutions, but I want to mention only this in this presentation. So as we are going to the end of our presentation, now Pavel will demonstrate we will demonstrate the demo. Pavel, so can we start now?
Yeah, sure.
Thank
so
you.
Let's start. Hope it will go smoothly. So what we have? We have prepared the environment, so let's go. So the first thing, what we are going to do, we are going to emulate, based on the software-defined network, virtual network DDoS attack, a simple DDoS attack, and all the emulation will be based on the following technologies and tools. The first one is as FlowRT. It's an analytical engine that receives a telemetry from the agent deployed on the network and transforms it into different metrics. So we can analyze and review the traffic flow visually. The second thing, what will be in use, it's a Mininet tool that creates a realistic virtual network on our internal network and can be interacted with built-in CLI. And the last one that will be in use right today, it's a REU It's a controller of software-defined network and designed to increase the agility of the network by making it easy to manage and adapt. So actually, it's a brain of our network that will be control and respond for different actions. So let's start from the installation, the main components. Actually, it's almost clean system without many tools. So I'm going to install right now the main part of all the packets required for today's demo. So let's go through them. The first of all, of course, it will be Java. We cannot do anything without Java runtime environment, so it has to be installed on the first stage. Then we are going to use Python and Python's package installer. It's required to install our Ryu controller. We will install additionally Mininet, some additional libraries that required for the proper and the main attraction of our demo, it will be a tool called HPing. Is an open source packet generator and analyzer. Actually, it's a very advanced ping utility, but not related. It's used for the security auditing and testing of firewalls, network, and etc. So that's the main tool that will be responsible for our DOS attack. So right now it's installed. Let's proceed with our Ryu. It will be installed in a few seconds. And additional packet related required for our Ryu controller. Right now we almost done with everything. We need Ryu.js. Frankly speaking, I've already copied it. It will be not generated written right now. I've copied from the sflow blog resource. There is a lots of different configuration and explanation how it can be used, how it can be configured, and different scenarios used different scenarios. So I'm recommend to review when you will have time and if you will be interesting. So it's this Ryu.js script was copied from this resource without any changes, and it works wonderful, just wonderful. So the last step, we are going to install our flow environment. So we have to download the archive and then just unpack it. Let's unpack it. It's done. So right now we are going to integrate our Mininet into the sflow analytical engine. It's done, and that's it. So what we are going to do right now, we are going to right now to start our Ryu manager that will control our network. On the second step, we are going to install start sflow engine. Just one small comment. We are going to start right now sflow without any configuration on top. I mean that we will not connect our Ryu.js script that will be responsible for detect and some additional actions while DDoS attack. So it will be just clean system, and in this system will be vulnerable for DDoS attacks. We'll just show you how it works. So let's start. It's started. We can see that HTTP port is open. So the next step, we are going to open the new window, find out the API address of our virtual machine. And let's open it in browser. Yeah. So we can see the web page of the main page with SFlowRT. We can see a different metrics. For example, we can see how many apps are connected, some performance testing of our network, and also on the apps page we can see our installed mininet dashboard. So let's open it. Right now, what we can see some graphs. So we will see the top flows. It's this graph is related to the traffic flow, top ports. So as soon as we will start our mininet network, we will be able to see activity of ports of switches related to our virtual hosts. And we can see the tab topology. Actually, right now it's empty because we didn't start our mininet. Let's do it right now. And it's started. So it's deployed, and we can see that switches are deployed and are available. So let's do the simple test. Let's see if we can ping all the virtual hosts. Yes, we can ping them. The next step is just to show how the traffic is flowing between our virtual hosts. We will run just simple performance command. So what we can see right now, we can see that traffic is flowing, we can see that ports are working, and we can see that there is a connection between our switches. So everything works fine. The next step, we are going to run our hping command just to emulate DDoS attack. It will be a simple flood attack on the UDP protocol. And let's see how it will work. So right now we can see that there is a traffic flow between the switches. So all the switches are up and they're working. And also if we will go to the charts tab, we can see that traffic is going through and all the ports are active. So let's stop it. This traffic is generated from the one single source machine. Let's imagine that the huge botnet, for example, as was described in my presentation, it was a Mirai botnet with 600,000 machines will generate the same attack, the same traffic. So definitely the resource which will be attacked will fail, because this amount of traffic, he will not be able to handle such amount of traffic. So the next step, we are going to repeat our tests, but with DDoS protection. Let's stop our environment. So we just stop mininet. Let's stop our SFlow, and of course we will stop our Ryu manager. So we will restart everything. Let's start from the Ryu manager. Ryu manager, we are starting the same without any changes like last time. Make sure, yes, it's started. Then next, we are going to start our SFlow RT. Remember, I told you that we are not, the first time we started it without any configuration on top. So right now we are going to start and connect our Vue.js script that will be responsible to identify and respond appropriately to the DOS attack. It takes few seconds and we can see that Vue.js was connected and started. And on the last step, we are going to run once again our mininet just to make sure that everything works fine. And we have deployed our virtual network. Make sure that we have ports are on. Let's do once again. Let's ping all the hosts. So the ping works well. All the hosts are up. We can see that ports are working as well. Let's perform again performance test. Short performance test. Yes, we can see that traffic is flowing. We can see that all the ports of our switches are on. And also, if we will go to the topology tab, we can see that there was a connection and switches was up as well. And let's perform our DOS attack. So let's start our hping with the same flute attack on UDP, and let's see what will happen. Let's start. So we just started. We can see that some traffic is generated. Yes, that's expected. Also, we can see that ports are on, but if we will see a little bit closer, we can see that there is only one port is working right now. And if we will look on our topology, we can see that switches are off. They're not working right now. There is no traffic flow between them. And of course, if we will refer to our as Flower team, we will see that we were blocked just because we started to generate malicious traffic. Let's stop our script and see what will happen then. We can see that our script responsible for the actions and monitoring unblocked us. So on this page, we can do performance test once again, and the performance test is reviewing right now as a legitimate operation. So it's not blocking us from anything. Also, we can do ping all operation. Nothing will affect our connection. So the Vue.js and the Vue manager understand that we are legitimate user and we should not be blocked. But in case if we will run hping once again, we will be blocked as soon as we will start our script. So this is explanation and presentation how the DOS attack can be executed and how can be mitigated in scope of virtual environment. But unfortunately, in very small manner. So
only on the network layer, right? Yeah. Wow.
Yeah. So that's it from our side. So I think that's it. And thank you. And we can proceed to questions. I think so.
Thank you, guys. It was amazing presentation. I cannot see any comments, any questions, because I think it's hard to understand on the flow, and our audience has to watch again, and maybe then they will come up with some questions. And I like to remind that the link to this recording session will be shared with all participants, and you can put your questions directly to our speakers, which contacts will be available. So, thank you all. Thank you very much for attending our meeting, our webinar. Keep calm and keep moving forward to your goals. See you soon. Bye.
Thank you very much.
Thank you.
Bye-bye.
Bye.
Thanks. Bye.
And protect yourself for the future. Have a nice day. Bye.
Thank you. Bye bye.